How can we describe uh, GIS? It's kind of map with a database behind it. We can explain GIS also as a visual representation of the real world and its infrastructure. Um, we can make queries uh, to support ongoing operations, summarize to support strategic decision making and policy formulation, and support scientific research. Um, you can see uh, different levels of information, which are,
Excuse me, we don't see the screen.
yeah, thank you. I will share the screen. Uh, can you see my screen?
Yeah.
Okay. Well, and you can see kind of P, uh, which consists of levels of cake and cream. So in our case, we can see spatial uh, levels of soil, wetland inventory, land use, digital elevation models, digital raster graphics, digital line graphics, hydrology, hypsography, transportation, roads, railroads, airports, country boundaries, etc., etc., etc. So we can use different information, combine it, and compare it, find spatial relationships between different layers. In the slide, we can see how GIS differs from related systems. Uh, DBMS, typical MIS data based on contains implicit but not explicit locational information. City, country, ZIP code, etc., but not geographical coordinates. Automated mapping. Primarily two-dimensional display devices that allow in digital environment. Uh, we often present thematic maps, for example, choropleths, business mapping software, so we can use also different geographical layers. And automated cartography, graphical design oriented, limited database ability. Another system is facility management. We have a huge amount of facilities inside city. We can present pipelines, electricity wires, and so on. But in this case, we have lack of spatial analysis tools. Another huge uh, group of software is so-called CADCAM uh, software. It means computer aided design and drafting, primarily 3D graphic creation, engineering design, and display systems. The main much famous uh, CAD CADCAM system is AutoCAD of the United States Autodesk company. Um, this CAD-CAM computer aided design software don't reference via geographic location. CAD sees the world as a 3D cube, but GIS as a 3D sphere. Um, computer aided design is limited, has limited database ability, and scientific visualization systems sophisticated multi-dimensional graphics but lack of database support, lack of two-dimensional spatial analysis tools. So, um, important question, why should we study GIS? Uh, Probably 80% of local government activities estimated to be geographically based. It's zoning, public works, streets, water supply, sewers, garbage collection, land ownership and valuation, public safety, and so on. A significant portion of state government has a geographical component: natural resource management, highways, and transportation. Another application is business. Every business often use GIS for a very wide array of applications. Retail site selection and customer analysis, logistics, vehicle tracking and routing, natural resources exploration. For example, petroleum, natural gas, coal, forest resources, mineral water deposits, etc. Another important now direction is precision agriculture. When mm, we can calculate precise area of agricultural land and get mm, very effective result of use precise fertilization, precise machinery use, and so on. Civil engineering and construction. Also, they use GIS and computer aided mm, modeling systems, military and defense, battlefield management, satellite imagery interpretation, scientific research, geography, geology, botany, anthropology, epidemiology, etc., etc., etc. So the future direction of your work after finishing uh, graduated from university, people or students who have got enough GIS skills can work for local government, public works infrastructure management, planning and environmental management. It's law, uh, direction, property records and appraisal, real estate and marketing, public safety and defense, natural resources, exploration, extraction, transportation, public health, and geospatial industry, data development, application development, and programming. And here you can see examples of GIS application in urban planning, management, policy. Um, let's uh, see particularly environmental science. Uh, Earth monitoring, land, forest, and sea surface and flow monitoring, modeling stormwater runoff, management of watersheds, uh, floodplains, wetlands, forests, environment and environmental analysis, hazards of toxic facilities, seating, groundwater modeling, and contamination tracking. So uh, we use GIS for manage, analyze, and communicate with different stuff. It makes possible the automation of activities involving geographic data, map production, calculation of areas, distances, road lengths, volumes, measurement of slope aspects, viewshed, uh, road planning, vehicle tracking, traffic management. Uh, Another important role of GIS is allow for the integration of data hitherto confined to independent domains. For example, property maps and air photos. By tying data to maps permits the communication of complex spatial patterns. For example, environmental sensitivity. GIS provides answer to special questions or special queries. How many elderly in the city of Richardson, for example, live farther than 10 minutes as rush hour from ambulance service? Um, it performs complex spatial modeling. For example, what is scenarios for transportation planning, disaster planning, resource management, utility design. Um, the main architecture and components of GIS is spatial data. So we gather and store spatial data about our world. Then we make query. This data are stored in geographic database, and uh, when the computer uh, works with this query, we can get a result, display and report, transform data, analyze data, and get all the necessary information for the decision making. Knowledge base for GIS. Here you can see um, um, some tags or some keywords that explain what does GIS technology is linked with. Computer, graphics, visualization, database, system administration, security, geography, cartography, landforms, statistics, application areas, public admin, planning, geology,
Bless
mineral
you.
exploration, and forestry, and so on. So main objectives of GIS is to develop an understanding of what GIS is all about, to understand the science behind the technology, to elicit uh, enthusiasm in using GIS as a tool for analysis and informed decision making. Here you can see 5 examples of spatial data visualization. It's digital elevation models. It's combining and uh, working with aerial photo, space images, land cover, maps, and satellite data from uh, spacecrafts. So we can see another pictures that can help to understand what is GIS. Uh, Widely speaking, GIS is every software that are working with spatially referenced information. Geographic is about the location of features, where these features are situated. Uh, the power of GIS is integration of data in a common data model. We can compare and understand dependencies, which data connect with other data. And we can find or learn how these objects interacts, are interacting. Features on a map, for instance, are pictorial representations of spatial objects in the real world. Symbols, colors, and line styles are used to represent the different spatial features on the two-dimensional map. Uh, GIS helps us not only to represent visual picture, but also get information about all these features. Historically maintained information as paper files, computer technology has enabled much more efficient handling and management of information within automated database management systems. Um, the second part of the 20th century was connected with the so-called system concept. This system concept explains that everything probably connect with everything. This can be strong connections or weak connections. Sometimes we cannot understand the if the connection exists. Uh, it's only one approach Um, because we have another approaches, for example, situation approach that um, do not explain our Earth as a system. However, system approach was and probably is very popular, and this term is used to represent the system approach taken by GIS, whereby complex environments are broken into down into the components parts for ease and understanding and handling, but are considered to form an integrated whole. So, system approach uh, combines two methods: analysis and synthesis. First of all, we break the system on its component, um, make research on every component, and then we can get complex, uh, holistic uh, understanding of uh, some features. Well, speaking about history of GIS, firstly in the United States, in the United Kingdom, in the Europe, in the former Soviet Union countries, uh, there are many geographers take part in the GIS elaboration. So the geography as discipline is strongly connected with um, GIS. GIS helps mapping spatial elements, and we use the same coordinate systems as um, for analog maps. We can explain location of points, lines, areas, and volumes in space by Cartesian grid, by Earth coordinate system. We can make mathematical transformation for uh, to show the Earth's surface on a plan. We use direction, scale, distance, etc., all the geographical concepts. Uh, GIS use the geographical mm, approach for spatial distribution. For example, pattern. What does it mean? It mean pattern. It means kind of spatial distribution. For example, city pattern of countryside pattern or wetland pattern. These patterns can be distinguished by using remote sensing data or another data, and these patterns can be model. We can make models of these patterns using GIS. Another important concept is density. We are of we are often we are speaking about people density, wild species density, fish density, contamination density, etc. So these densities help us to make borders, to make to understand spatial distributions. So another concept is concentration. It's very similar to density. Mm, However, speaking about density, we must distinguish units uh, which are situated dense on a surface. On the other hand, concentration means concentration of chemical contamination or radioactivity. Spatial order. Uh, Last few centuries, geography make uh, big steps, big progress in understanding spatial order. Uh, its concept of regional development. That means uh, that the Earth's surface can be divided in so-called regions. Uh, these regions, every point of the region is strongly connected with the center of the region. And when the small village is on the edge of the region, um, when we moving far from the center, uh, we can find the point when another village is much more strongly connected with another center. So this regional concept helps us to divide the territory on these regions which have different uh, different levels of different indicators. Also. Um, Spatial order of physical and human features. Well, uh, understanding relief uh, spatial distribution, we can explain why all the rivers run in the direction of the ocean. Human distribution is also connected with settlements network, with road networks, and make kind of grid with different spatial density of people and economic activity. Another complex concepts of spatial interaction, agglomeration, which means concentration of activities in the center. For example, Tokyo agglomeration, where 4 or 5 cities are situated so close that it is not easy to distinguish the cities, and we are speaking about Tokyo agglomeration or concentration of different units. Accessibility. How can we access to resources to different points of territory while using, for example, not road network connectivity? Uh, how different parts of territory connect. Uh, Central domination modeling. I will show you examples of the central places theory that worked by von Thunen, Kristaller, Walter Kristaller, August Lösch, and other scientists. Spatial transition. It's idea of some objects and features change their occupancy over time. Spatial diffusion, transfer or movement of object entities, people, ideas, diseases, for example, COVID-19, etc. And big landscape concept that explain anthropogenic and natural landscapes and cultural landscapes and so on. Well, GIS are closely related with different academic disciplines, with geography, computer science, mathematics, statistics, and information science. Well, the main technical part of every GIS is data, but these data are stored in special purpose digital database. Um, we have some kind of joke. What is the similarity uh, of GIS and uh, your grandmom activities? Who can explain me? Probably someone can find the similarity. Huh? Who will try?
I could explain to us about my my grandmom activity or what?
No, I ask you, can you find the similarity between GIS and strawberry conservation?
Uh, it's also so slow.
Do you like strawberries? Do you know what does it mean, strawberry?
Yeah.
I will type down.
I don't have any ideas. Maybe 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 similarity in monotonously. I don't know.
Strawberry, yes?
Yeah,
This is small red berries that we can find in a straw between grass in the forest or in the meadows. Yeah.
yeah.
So, and girls, probably girls can help us to find the similarity. Anna, Anastasia, probably girls are fell asleep. Yeah.
No, no,
Maybe.
no.
No? Do you like strawberries?
Yeah, sure.
Well, uh, who can explain me how can we got strawberries for our breakfast?
We
First
need
step.
How
to take it.
Need to what?
take it
Take it from where?
from garden or from by store?
Well, absolutely yes. The first step is gathering. Uh, A very similar process is gathering spatial data. Or another term for gathering spatial data is spatial data capture. We can find this data and put it in our database. Yeah. The next step that we should make with our strawberries.
We need to
To eat.
restore them.
No,
Oh, sort them for bad and good days.
we can prepare
Oh, yeah.
prepare the strawberries. For example, to wash them up, or to make a jam, or make a pie, or make an ice cream with strawberries, etc. Uh, the also we make this step with data, with spatial data preparation. We must work with this data and prepare it for manipulating. Another step, if we have many strawberries and we cannot eat it all at the moment, what should we uh, done with the strawberries? Hello?
Yeah.
I ask a question. If you do not know the answer, please inform me about
What we
this.
should done with
We in
strawberries?
processes.
You are in process.
In
I
process of collecting
Of
strawberries.
thinking.
well, it's much better when you inform me about your process. It is June, for example, now, and we want to use the strawberries on December. What should we done with the strawberries?
We need to conserve strawberries.
Yes. Another step is uh, store the data. We need to put our data in the data store, in the big library, on your hard disk, or in a cloud, on the net. So the fourth step is data manipulation and use. The last step is just uh, as our strawberries analogy is eat the strawberries or use our spatial data. So the process of strawberries conservation and GIS uh, data link, data management are very similar. Now we must make a break.